Hi students, today we're going to look at a couple of different strategies using identities. Specifically, we're going to look at identities that would be helped by the use of either conjugates or by the use of some common denominators. The first one we're going to look at is one that uses some conjugates. Just as a reminder, if we have an expression, in this case we're going to look at 1 minus cosine of x. Its conjugate would be 1 plus cosine of x. The reason that these are cool is because if I were to multiply these statements, and we're going to do this in just a minute, when I multiply them out, we end up getting a middle term, plus cosine of x minus cosine of x, that cancels out. When we do that, that lets us do things like say, okay, well, 1 minus cosine of squared, well, that's the same as sine squared, and now I can kind of play with some things. But let's see how this looks on this problem. So I've got sine squared x on top. I've got 1 minus cosine x on the bottom. If I see something like this, I want my instinct to be multiplying by a conjugate is going to be really helpful. On the bottom, that gives us 1 minus cosine squared of x. We already did that math out on the right. And the top, I'm not going to multiply this out. The reason I'm not going to multiply this out is we're going to see something in just a minute that is going to be useful for us. Because 1 minus cosine squared of x, if you think back to our Pythagorean identities, is the same as sine squared of x. So we can rewrite this as sine squared of x times 1 plus cosine of x over sine squared of x. Those cancel out, and that's equal to 1 plus cosine of x, which is what we're trying to do. When we're using conjugates, our goal is often going to be to then use some kind of Pythagorean identity to finish the problem up. The other strategy we're going to look at here is using common denominators. And this lets us find ways to combine things that are not combinable. So like 1 plus secant of x. I'm going to rewrite that as 1 plus 1 over cosine of x. And now I'm going to find some common denominators, because this is really 1 over 1. So if I were to multiply this by cosine of x over cosine of x, I could get cosine of x over cosine of x plus 1 over cosine of x. When I do that, I've got cosine of x plus 1 over cosine of x, and that's what we're looking for here. All right. Looking at the first one on this page, I've got tangent squared of x minus sine squared of x. I don't really have any way to combine those, so let's see what I can do. Well, I know that tangent I could rewrite as sine over cosine, so maybe write this as sine squared x over cosine squared x minus sine squared x. Now I could do a common denominator. I forgot my squared there. So I could write this as cosine squared x over cosine squared x. When I combine these two things, we've got sine squared of x from the first part minus sine squared of x cosine squared of x over cosine squared of x. So now I can factor something out of the top. I can take a sine squared out. And when we do that, we've got 1 minus cosine squared of x. On the bottom, we've got cosine squared of x. Okay. We've got two pieces here. The first is sine squared x over cosine squared x. That's going to be tangent squared of x. The second is 1 minus cosine squared x. That's one of our Pythagorean identities for sine squared of x. That's what we're trying to get to. Looking at the one that we have on the right, I'm going to rewrite this in terms of sine and cosine first. Cosine of x over sine of x plus sine of x over cosine of x. Let's find some common denominators here. And on the right, I'm going to get sine x over sine x. On the left, I'm going to get times cosine x over cosine x. Cool. So the top of this is going to become cosine squared x plus sine squared x. The bottom, cosine x times sine x. Hopefully we realize that cosine squared plus sine squared is going to be 1. So we got cosine x sine x. And what we're going to do is say that 1 over cosine x is secant of x. 1 over sine x is going to be cosecant of x. And that's what we're trying to get to. All right, so let's take a look at this one. I just tried this before I recorded as dealing with conjugates. It went down a really nasty rabbit hole. So instead, I'm going to think about this in terms of some common denominators. So I'm going to rewrite this as 1 plus sine x over cosine of x over 1 plus cosine of x over sine x. For the top part of this, I'm going to turn 1 into cosine x over cosine of x. And for the bottom, I'm going to turn this into sine x over sine x. So we end up getting cosine x plus sine x over cosine of x. I'm going to do the same thing I've been doing when I have these complex fractions and rewrite this as a divide with the fractions side by side. This one's going to have sine x on the bottom and sine x plus cosine x on top. Rewriting this, we've got cosine x plus sine x over cosine of x times sine x over sine x plus cosine of x. Since these are exactly the same, those cancel out, leaving us with sine x over cosine of x, which is tangent of x and our goal. All right, for the next one, I see the 1 plus sine x, and it's all by itself here, so I have a feeling that might be a conjugate thing. I'm going to hold off on the beginning part of this for just a minute and leave that as sine x over cosine of x. For the second part, I'm going to write this as cosine of x times 1 minus sine x. And the bottom, it's going to be 1 plus and 1 minus, so 1 minus sine squared of x. I'm going to rewrite that as cosine squared of x, and one of those is going to cancel out. So we've got sine x over cosine x. Here we've got 1 minus sine x, and cosine x is what's left on the bottom. After we reduce that, that gives me sine x plus 1 minus sine x over cosine of x, which is 1 over cosine of x, or secant of x. We got a couple more of these to give a shot to. For the first one, we've got 1 plus tangent of x and 1 plus cotangent of x. I was doing a little bit of Freudian slip there. We have identities for both of these. 1 plus tangent of x is tangent squared of x, rather, is going to be secant squared of x. 1 plus cotangent squared of x is going to be cosecant squared of x. And once we have that kind of set up, we can begin to kind of think about what's happening here. So secant, and I'll keep these color-coded, is going to be 1 over cosine squared of x. We're going to divide these horizontally. Cosecant is 1 over sine squared of x. Converting these into multiplication, 1 over cosine squared of x times sine squared x over 1 is equal to sine squared x over cosine squared x. That means that tangent squared of x, which is what we have there, is equal to tangent squared of x, and we are done. For the next one of these, I can see that I've got two things that potentially could be conjugates, and I think that's a good way to start this. because if I do this as 1 minus sine of x and 1 minus sine of x, this first thing becomes cosine x times 1 minus sine of x on top. And at the bottom we have 1 minus sine squared of x, which is cosine squared of x. Okay. For the part on the right, if I multiply this by 1 plus sine x and 1 plus sine x, we end up getting cosine x times 1 plus sine x over, and hopefully we know this is going to be cosine squared x on the bottom because it's going to be the same thing we had in the first one. In both of these pieces, we've got cosine squared in the bottom and a cosine on top. That can cancel out one of those cosines for each. And we're left with 1 minus sine x plus 1 plus sine x all over cosine of x. Minus sine plus sine go away, leaving us with 1, 2 over cosine of x. We know that's the same as saying 2 times 1 over cosine of x, which is 2 secant of x. All right, last ones. We've got some weirder things going on here. We've got 1 minus cosecant squared of x. Okay, that's one of my identities, although we have to rearrange it a little bit. That's going to be 1 minus cosecant squared of x is equal to cotangent squared of x. So that's going to be negative cotangent squared of x. And I also would like us to notice we have a negative out front here that's a little bit hard for me to see on my screen, but I think you can on yours. So I could write this as 4 cotangent of x on top. I'm going to put that negative with that 4 to make it easier. And then the bottom, we've got negative cotangent squared of x. Negatives cancel. Cotangent cancels in the bottom with 1 on top. We've got 4 over cotangent of x, which I could rewrite as 4 times 1 over cotangent of x, or 4 times tangent of x. For the last one of these, I've got sine to the 4th minus cosine to the 4th is equal to this stuff. This is going to be a weird factoring problem. If you'd prefer not to factor, you can start on the right side. And looking at the left side instead, which is how I'm going to factor this, I notice this is a difference of squares. So I could write this as sine squared of x plus cosine squared of x times sine squared of x minus cosine squared of x. The cool thing here is that our first piece is equal to 1. And then we got sine squared x minus cosine squared of x. Okay. Now I'm going to use some Pythagorean identity. I know both of these have to convert into sine because that's what my final answer should look like. And I've already got sine squared of x. Cosine squared of x using Pythagorean is going to be 1 minus sine squared of x. And when I combine those, we end up getting sine squared of x minus 1 minus minus is plus sine squared of x. So that's 2 sine squared of x minus 1, which is what we're trying to get to.